I'm Christopher Dow, and I'm here to talk about IoT architecture. So I think I'm just going to jump right into this, and there's some introductory stuff at the beginning, and we'll go through it. So what I want to talk about covers, not just what you need in the end, but how do you build what you need in the beginning with an eye for making sure you're ready for what's coming in the future. And, often we don't know what that is, so it's kind of an interesting topic. The topics we're going to cover are a brief introduction to myself into August, so you can understand, sort of how we learned what we've learned. And then we'll go into the broad strokes of IoT architecture and dig in fairly deeply there. And then go through things like language selection, framework selection, databases, and then at the end, how we put this all together to create a user experience. I'll have a couple of examples of that. So first off, what is August? Actually, 3 years ago yesterday, we launched the August Smart Lock. And that was our only product. It worked with the mobile phones. And to the extent that it was an Internet of Things thing, that was done through backhauling data from the phone. A few months after that, in February 2015, we launched our Wi-Fi bridge. The bridge actually does connect over to the lock, over Bluetooth, and really brings the product into what you would really call, the Internet of Things, where you can access it remotely, you can collect data from it remotely, it's online all the time. And that enabled us to create a whole lot of user experiences around, better monitoring of how the product was performing and things like that. Then in 2015, 2016, we introduced the smart keypad and the doorbell camera. The keypad also only connects to the lock through Bluetooth, but with the bridge, you can do all kinds of things around settings for how the keypad works and things like that. And then the doorbell camera, which is another fully internet connected device. It's got a camera, it's got Bluetooth that has Wi-Fi, it can operate the lock, and it can, of course, record what's happening outside your door. It also is a two-way communication device, provides video from the camera and then audio back to the camera to communicate with whoever's standing outside. Why should you care about what I have to say about that? I started my career, as most people do, as an engineer, doing the dirty jobs that engineers do, writing a lot of low-level stuff. Over the course of my career, I moved amongst being an architect or a principal engineer, being a manager, and back to being an individual contributor. In fact, when we started August, I was the only engineer in the company. So, there was nobody to manage but the voices in my head. So I ended up writing a whole lot of this. Of course, over the years, the engineering team is more than 35 people at this point. So there's a lot of, and that plays into what I'm going to be talking about as well, not just how you do things for yourself, but how you do things so that when you do hire more people, you can hire the right people and they can work on what you're building, and they do so in such a way that your architectural intent is preserved. So what does IoT look like? Well, we start with, what does IoT architecture look like? We start with the canonical IoT architecture, which really isn't that different from any other architecture. You have a user interface. People need to interact with these products. They need to see the data that they're generating. They need to see how the products have performed. So we've got to have a user interface. The products themselves need some interface back to a back end that helps them, where they either deliver their data or they get parameters for how they should operate. And then you have external interfaces. Unless you're going to do everything yourself, you need to interface with some external services. And in fact, it obviously interface with a number of external services. Underneath all of that are your typical logic, relationships, and rules. These things are in places. There are people who have access to those things. They're basically grouped. And all of those operations are done based on data, and data is coming in and out of the system all the time. So it's pretty simple from this level. And in fact, in the beginning of August, this was a pretty good reflection of the actual system. things were pretty monolithic. But over time, we had more functionality we needed to achieve, and we needed to start splitting things out. And then as we split things out, split them out in such a way that you can add new things. So this is what it starts to look at like after a while. You have a lock connected to a bridge. We have iOS and Android UI. There are small web UIs. There's like a lost phone flow and a few other things that are actually single page web apps. They don't provide a whole lot of functionality because we really believe that people want to interact with us through their mobile phones. But they do provide some. We have the bridge and the camera that both have to talk to our services, and we have partners that you consume our APIs. Comcast, Logitech, various other companies, allow the operation of an August Smart Lock through their system. And then, you have other external services. We didn't build an SMS system. We didn't build a system to send emails. We didn't build a system to send push notifications. We use other services for all that. So all those things have to be hooked into your backend as well. And I think these notification type things have become very important for any IoT device. I mean, people really want to know. I think it's important to tell consumers when the product won't work. One of the most important determinants on whether or not an IoT device will work is whether or not it has network connectivity. And that is not something you as the developer of the product can control. It actually is something that's under the control of the consumer. So it's important to let them know when their network has failed, when their internet connection has failed, when their Wi-Fi has failed, and say, hey, I don't see this device anymore. Underneath all of that, we have locks, we have keypads, we have doorbells, we have access to those things. Who are you going to let in your home? Who you're not going to let in your home? Who can see the camera but can't get it, or who can get into your home but not see the camera, and all sorts of things like that. And then that, of course, is sitting on top of databases. And now we bring in sort of an internal communication layer because you can't have all these things sitting in one monolithic service. So you've got to break that out in a very, very different way. And that's what we'll show next. And this is the system as it exists today. We have mobile phones, Android and iOS, talking to an API service. There is a specific service just for the bridges. That basically when you say you want to unlock the door, the mobile phone, and you're not home, the mobile phone makes a REST call against the API service, which then communicates with the bridge service to say, I need to tell this lock to unlock. The doorbell service has its own very, very similar set of things where it's basically communicating that it's recording video and getting information about where to store that recorded video in the cloud and various other operational parameters. Both the bridge and the doorbell share a configuration service. So there's a service that they hit as soon as they come up that gives them the information they need regarding the other services they should talk to, and also communicates to them where they should be getting firmware updates and things like that. Next, we have the Nest service. Nest provides a HTTP streaming API. So there's for everyone who's associated a Nest camera with an August lock. The reasons why people do that is now with the doorbell camera, the lock, and the Nest camera, you can get a full story of what happens when somebody comes through the door. You can see them walking up to the door. You can see how they got in. Then if the camera's on the other side pointing at the door, you can see what they did when they came through the door. So that becomes that's an important part of August business, is telling stories about how people get into homes. So the Nest, for every Nest camera that's associated with an August lock, there's an open HTTP connection, and we basically are constantly getting information from that regarding events that are happening on the camera. And if those events happen anytime when a lock operation happens, they're included in the activity feed for the lock. And then we have Alexa and Google Home, which are each their own service that we have built that connect to those services so that you can say things like, Alexa, unlock my door, or okay, Google, unlock my door. Although I think with Google, it's only locking the door. With Alexa, you can unlock the door using a PIN. So nobody can stand outside your house with a megaphone and say, unlock the door. And then lastly, we have the OAuth service that basically, for anyone who's trying to connect an external service to August, this is how that happens. We chose MongoDB and Redis for our primary data stores. Really, all the permanent data is in MongoDB, and there's also a Redis for real-time communication and anything that doesn't have to be persistent. We do use RabbitMQ to coordinate information between the various services. For example, if we need to send, if the API service determines that a notification using SMS, GCM, APNS, email, or actually companies like Comcast actually subscribe to web notifications. They give us a URL, and then when a lock is operated, we post to their URL informing the customer's Comcast account that someone has unlocked the door or locked the door. And then we have billing, because we do have a subscription service relating to the doorbell camera, so for DVR. So all of those things, are separate, and how we manage all of that is by using RabbitMQ to send messages to various parts of the system. So even beyond that, in reality, that's what I showed in the last slide is what one instance of our systems of services looks like. In reality, we actually are deployed into 3 data centers, and then we use DNS to fail over if something goes wrong. And a little bit later on, I'll describe the various kinds of things that can go wrong. But in order for an owner to unlock an August lock, it's not required that they have internet connection, but for a guest, it is required. So we can't have guests at people's homes actually sitting outside and waiting for our service to work. So whenever something bad happens to one of our data centers, we fail over using DNS to the others. So let's talk a little bit about language selection. First, I want to talk about principles. When you're starting out, you want to make sure that by the time you've released your product, you're in a good place. You want to have a situation where you're able to hire talented engineers to work on the platform 3 years from now. You want to make sure that the platform, the language that you've chosen, is supported, not just supported in working on your platform, but does that very well. And especially if the platform is the IoT device itself, that's not something that's going to get any faster ever. It's going to exist until it stops functioning. So you really want to make sure that whatever language you're using has quite a bit of headroom on the platform that you're working on. The next thing you want to really look at is how specialized is the language. There are a lot of people who can write software in JavaScript. There are a lot of people who can write software in Java. There are fewer people who can write software in Go. There are even fewer people who can write software in Erlang or Haskell. These are all things that really have to be thought about. In some cases, for a while, there were very few people who really were proficient in C. That's changing because of the Internet of Things. It's sort of revived embedded software development. So there's actually a lot more people who understand C today than I saw 10 years ago. But all these principles need to be applied to the selection process that I'll go through in the next few slides. In the back end, scalability really is a big deal. I really can't overstate that. If you sell even 40,000 things, there are going to be 40,000 things that are connecting to your service all the time. And you've got to be, in some cases, they need to connect, every couple of minutes and give new information. So that it's, even with a moderately successful product, you end up with a decent amount of web traffic that has to be dealt with. I think when you're first starting out, it's a really good idea to bias towards the cutting edge, because that means that when you're actually, when you're starting to become successful and you really are having to worry about scaling, you're going to be in a situation where you're using pretty modern technology and technology that's attractive to new developers as you start to actually scale your organization as your business scales. One thing that's important to know is that frameworks can really, really hurt you. Ruby's a great language, but Rails is not a great framework for scaling. I was in the same office building as Twitter during the Arab Spring, and I can assure you their ops people were really pulling their hair out that spring because their Ruby on Rails implementation of Twitter simply was not functioning. And there were probably people inside the organization who wanted to move to something else before that happened, but the business need to do that wasn't obvious until they actually were, very, very heavily affected by the huge amount of increase of usage during the Arab Spring. I think it's very important to be aware of systems where development is easy, but scaling is difficult. I've seen this with, as I mentioned, Ruby on Rails, also seen it with the .NET frameworks. It can be very, very easy to get something up and running and working, but getting it to scale can be, very expensive. And so in the end, what Twitter had to do was just scale horizontally at a huge cost. And you can very easily get to that corner with .NET frameworks as well. So for mobile, there aren't too many choices. You've got, on Android, there are options that are not Java, but I wouldn't recommend using them. On iOS, I think it's important now that Swift is out. Swift does a good job on most UI things. Use Swift where you can. Use Objective-C everywhere else. There are certain frameworks on iOS that you just can't use Swift. So you have to basically, if you want to use Core Bluetooth, you got to use Objective-C. But by using Swift and a combination of Swift and Objective-C, I think you can really broaden how many developers you can hire, and you're also using the newer technology that's more attractive to developers today. That's one of the key things I've learned over the course of my career is that developers really want to work on sexy new technologies. So on the device software or firmware, this one is, there are some real options today that didn't exist even 5 years ago. However, for true embedded, or if it runs on batteries, you really should just use C. I mean, obviously, it's not going to be a huge platform anyway. There's not going to be an enormous amount of code. So I think C is a really good option. It does what you tell it to do with very few surprises, and that becomes very important in the world of very, very small things. If your platform is a little more robust, you can use C++, but I would strongly avoid using STL. I mean, you typically, STL really is built for, user interfaces on, desktop computers or laptops for that kind of software. Interestingly, my recent experiments with prototyping for August 2018 and 2019 products have shown that Node.js and Go language are actually real options if you can support a landed cost of $20 US. And by landed cost, what I mean is that's your total bill of materials plus, cost to manufacture plus packaging and shipping to your distribution center. So there are multiple options in that price range that will run those languages quite well. And if you are able to do that, then you can pull on a pretty broad pool of developers. And back inside August, we are actually looking at, in our 2018 and 2019 products, actually having some of the developers who have been working on the back end start to work on the on the devices themselves, because we're going to be able to deploy these technologies to them. So framework selection. What we need when we are deciding on frameworks, we need something that is both cheap and fast. We also, I think it's very important to use other people's electricity. And what I mean by that is that if you have a web interface to your product, I think it's very important to have all the heavy lifting of that interface be done on the mobile phone, in the browser, etc. This is because it's basically free compute. You don't have to pay for it. And that's one of the things that has been the bane of many, many companies as they scaled. You look at companies like MySpace and Friendster, who were doing full PHP backends where they generated all the HTML and CSS on the back end and then delivered it to the browser. And they had terrible scaling problems. As single-page web applications were developed, it becomes a lot easier to just say, here's some JavaScript, here's some HTML, here's some CSS. You go execute that on your platform and have your backend be something that is strictly an application programming interface and does not generate any UI itself. You want something that's fast to develop on, fast to deploy, and runs fast. So, I mentioned before the .NET, Ruby on Rails. They are fast to develop on, they are fast to deploy, but they're not fast to run on the systems when they're actually deployed. So that's a very important thing to understand. You need to pay close attention to, what is the actual compute that you've got to deal with, because now we're renting computers and we're scaling computers, and understanding the performance implication of your backend code is, I think, more important today than it has been in the past. So another question to ask when you're looking at a framework is, does it scale? I keep harping on scaling. Will it do what I want? When I started working on things for August, I actually was trying to use Ruby on Rails. And what I found was trying to get Ruby on Rails to make a straight up application programming interface, just an API or REST API. It was clearly possible, but it really felt a lot like trying to put a wagon wheel on a car when you get a flat tire. It clearly wasn't a fit. And when I finally came across, Node.js and the Restify and Express kind of frameworks, I saw this is actually designed to do what I'm trying to do. So that's a really important thing. Is it really made to do what you're trying to do? The next question is, does it make it easy to do things the way I need to do them? Am I going to have to jump through hoops to make this thing just have a REST API, or is it something that it just naturally does? And the last one is, if there's something you don't want people to do as you grow your business, does it make it easy for them to do that, or does it make it difficult to do that? One of the reasons why I settled on Restify instead of Express in August is that the Restify framework makes it very, very difficult to generate web pages in your back end. It's a pain in the butt. You've got to really, really try hard to do something that we don't want to do. So the natural inclination is going to be to build things the way we want them built, because that's the easiest path forward for the developers. So now, databases. Polyglot persistence really is the answer. And if you don't know what polyglot persistence is, it means using different kinds of databases for different kinds of data. That's fundamentally what it means. So what you need here is you need performance, you need reliability, you need robustness and fault tolerance. Those things are available in every database, but not necessarily available in every database the way you need it, or for the kind of data that you have, or how you want to access your data, how you want to deliver your data. They're just different solutions for different problems. So, I think it's really important to understand how your system is going to work when you start off. For example, I knew when we started to build August that the system was fundamentally going to be read heavy and write light. So there are the amount of data that comes into the system from the user's perspective is small. It's things like, I added someone to this lock. I gave someone access to this lock. I took away access from that lock. Somebody unlocked the door. Somebody unlocked the door. These are all things that happen at the speed that humans do things. So getting data into the system wasn't going to be a problem, but I did feel like we needed to get data out of the system as quickly as possible, especially when you look at things like guests to an August lock actually have to have access to our backend. Our backend must get data out of the database in order for them to initiate communication with the lock. So that becomes, that's a very important input. It has to be fast, and it's got to be reliable. So in the end, we settled on MongoDB for that. Basically, it fits the bill there. It also has excellent failure recovery. MongoDB replica sets work very well. My previous slide where I showed the 3 data centers, there is a MongoDB replica set that goes across all 3 of those data centers through the VPN connections that I showed. So when a key system goes down, it just fails over, and that works very well. And unfortunately, I've had an opportunity to test that a lot, as we'll get into later. But so as far as performance goes, it is kind of subtle. You've got to have access to the data. You've got to have that be very fast, but you need access to the right data. Any key value hash system will actually get you fast access to data, but the question is, if you want to know which data you want, you've got to get it all out and look at it. So that doesn't work. So you need to find something that's a balance, that basically there may be certain things that you really can just store by a key value, like information around the user. You don't really need, if you already know the user, then that's easy. But oftentimes you do need to query. And a lot of times strict document stores will pull the documents fast, but you can't really query them. So this is another area where I think Mongo does really well. It's a good balance between being able to have a decent way to query things out of the system and have it be fast and have the failover redundancy. So when I'm talking about reliability for databases, what I really mean is consistency. And if you're actually doing transactions where as soon as you have written the data to the system, the entire system has to be consistent, because it's something like a bank account. You don't want people to spend more money than they have. Then you really kind of have to use an RDBMS. You have to use SQL. I'm sorry, because those systems, you can make SQL systems scale. And in fact, if you look at things like offerings from Amazon, there are actually, the question really becomes, does your business allow you to let someone else have that data, or do you have to have strict control over that data? At August, we feel like that since our product allows people into other people's homes, we really have to be strict about who has access to the data. Otherwise, look at other systems. In the case, most of these systems use eventual consistency. You really have to look and say, is eventual consistency good enough for your application? What we found in practice with August is, we actually know within a very, very reasonable amount of time, when someone has unlocked a door, it's in the database. The next time you go look at, the history on a lock, you can see what's there. It works well. But, your application may vary. It's something that you really need to pay attention to when you're selecting a database. So for robustness and fault tolerance, disks fail, computers crash, people unplug routers. In 2014, there was something called the Zenpocalypse, where both Amazon and Rackspace had to reboot every single one of their computers because of basically a privilege escalation hack. It's called a VM escape. So you can escape from one virtual machine into another virtual machine. The question is, how long will your service go down when something like that happens? And the answer needs to be, so it will go down for such a short period of time that people generally won't notice that it happened. And this is where, you've really got to look at it, not just how well you can develop for this platform, how quickly you can deploy new functionality to the platform, but what does it really look like when it's sitting in the real world and having to operate in a world that is not perfect. So, putting it all together. And then the last example I'll give is viewing a camera. In this case, what happens is you take out your mobile phone, you open up the August application, and as soon as you open up the August application, the mobile phone actually sends a real-time message to the doorbell camera itself, actually bypassing our backend. And this is an important thing, that some sort of real-time messaging system, either the Amazon IoT messaging, PubNub is also a good solution there. These things make it so that you can sort of queue up activities. In this case, the camera generally is not doing much. It only records video when it's got stimulus, like through infrared or somebody's actually pushed the button. So in this case, when you open up the August application, it actually sends a message to the camera saying, hey, wake up, somebody may want to look at video. And our goal is to just minimize the amount of time between when you say, I want to see video from this camera, and when you actually start seeing video from that camera. I don't know if you have a internet connected camera, sometimes that can take a while. We wanted to avoid that. So when that happens, the camera actually tells the backend, it says, hey, somebody woke me up and wants to do video, and I'm creating this session now. I need a recording session ID, and I need information about where to store this video as it's being recorded. And at the same time, the backend actually notifies all of the people who care about the camera that someone is watching the camera. So you know that it's like, I'm not going to be able to look at this camera because someone else is looking at it right now. So, and then lastly, one of the things that the doorbell camera can do is it does also act as a bridge. So the user can actually unlock the door through that. So, okay, that concludes my talk. I think I've left 6 minutes for questions. So I'm going to switch back to video and take any questions you have. The question was, how fast did we develop the prototype? For the lock, we went through several iterations. We started actually with another company's product, and then we started with another company's product, and we built our mobile application and our backend around that. And then we decided that the product this is actually the product we demonstrated at the D conference in 2013. And in the end, we decided this thing didn't really work well enough for us. But the nice thing is that then we could switch over and start building the lock. So we started building the lock that we first sold in April of 2013, and it came on the market in October 2014. So, you're talking about 14 months. Well, is that right? I think 16 months. So, it took a while. It took a while. I think that really answers the first and second question. How fast did we develop the prototype, and how long did it take for the smart lock to be fully developed? The next question is this like a microservice architecture? And I think the notification system, every time we communicate externally, that really is pretty much a microservice architecture. You basically are sending a message to a smaller service that is just doing one thing. As far as the prime, the main logic relationships and rules and things like that, that is a monolithic service. And then the application servers that deal with the bridges and the doorbell cameras they're more like full-scale services than a microservice. But when it comes to the external notifications and interfaces to external things, that really is where we have a microservice architecture. So the next question was, did we take help from some well-known ODM? So for the initial lock, we designed it ourselves. We did hire a company that was a design firm to help us with the mechanicals and some of the electricals, but we did most of the electricals ourselves, the PCB and all of that. And then that was, the locks have always been built by a contract manufacturer. We started off with a company called Generate in Sunnyvale, California, which was very nice because when we had problems on the manufacturing line, we could get in a car instead of on a plane. We did transfer the manufacturing over to Flextronics in China, and but that was after we had a fully specified product. And Flextronics continues to be the manufacturer of the lock. As far as the doorbell camera, the bridge, and the keypad, they're basically all what's called as a JDM. So we're doing a lot of the electrical design. We're doing a lot of the mechanical design. They're sourcing the suppliers inside China and managing the manufacturing, but it's very much a joint effort. They're helping us with the design. We're validating their stuff. They're validating our stuff. And I think that, if you really are going to differentiate, if your business is going to differentiate based on software, I think the ODM model works really well. But if your business needs to differentiate both on software and hardware, then I strongly recommend the JDM or contract manufacturer model. It's very hard for small organizations to do contract manufacture. It was actually a huge risk that August took in the beginning. But in some ways, when I spoke about we had the original lock that was manufactured by another company, that was really kind of an ODM model where they were building the product, but we just decided that product wasn't what we needed. That wasn't going to. It was not a product we wanted to sell. It's my pleasure. I appreciate your attendance.